Hey math lovers, let's go over lesson 8.5, estimating population parameters. What's our learning goal, our learning targets here? Our standards for mathematical content is students use the sample data to make inferences about the population. I'm very fortunate. I get a lot of surveys to get data from me. And I get these emails and they say, what do you do? I'm a teacher. And then they might ask me like, what kind of curriculum do you use? What kind of teaching methods do you use? What type of supplemental material or technologies would you like to see? And what they're trying to do is they're trying to get some data from me. Like, what do I think is helpful for students to learn math? And I get paid to do those surveys. Now, sometimes those boring surveys, if they're not going to pay me, I'm probably not going to take them. That's why, at the end of your receipt, like if you go to McDonald's, Jack in the Box, they always ask you, want to take a survey, and they're willing to pay you. They're trying to get some sample data to talk about the whole population. All right, how can we meet this standard? I can use sample data to make inferences. About the population parameters. All right, let's go to our warm-up over here. I have four numbers, 8, 10, 14, and 15. Go ahead and press pause. Try this on your own. See if you can do this on your own, and then press play if you want to do it with me. All right, it tells us to write all the possible selections of a sample size 3. So I just need groups of 3. But there's four numbers here. So maybe you have like 8, 10, and 14. Or maybe let's skip 10 this time. 8, 14, 15. And then how about 10, 14, 15? So it looked like I used 14 3 times. I have not used 8 3 times, so how about 8, 10, and 15? Okay? So there they are, and then it tells me to find the mean, or the average. So all I have to do there is x bar equals, I add up all of the numbers, and I divide it by the number in my list. So for example, that would be... do that in a different color over here. If I add up all of these numbers, and there's 3 numbers in the list, I divide it by 3. This would give me a mean of 32 divided by 3. So I'm just going to use the calculator for that. Let me take a screenshot. Picture with my cell phone. There it is. Then I'm going to show you. I use this thing called Graph and Calc 83 over there by my Cooking Fever. And then we're going to press Stat button next to the left arrow. And then I'm going to press Edit. And then you can go up to the list. So this mimics a graphing calculator. So if you have one, or if you need help getting one, the school cannot provide you one, but you can download one like this on my tablet, your phone, or I can tell you other ways to get like used ones. All right, so the first one was 8, enter, 10, enter, and then 14. And then that's in L1, so I'm going to press now Stat, left arrow, Calc, so next to the edit, and then 1 var stats. And remember, your default is just L1 in here. But if we need to, we can. So I'm going to press second, the orange button, and then number 1, because that'll give me L1 in orange. And you don't need to close it. And there I have my average, 10.66666. And just to review your rounding, this is the one that we need. That is the hundredth. So I need to actually look at this number. If this number is 5, 6, 7, 8, or 9, then this number is going to go up So my answer is going to be 10.67. And let's go ahead and put that in for the rest of my numbers. Stat, edit. You can do the same thing in this list again if you want to. So now I have 8, enter, 14, enter, 15, enter. Now you have to press enter on that third one so that the 3 numbers are inputted, and press stat, calc, one of our stats, and you just press enter. And there at my average is 12.33. 12.33. Now, even when you're doing your calculator commands, I saw in your those who turned in their work last week, you might want to still kind of show a little bit of work. And all the work you need to is actually still in your calculator. Let me show you. Summation x is underneath x bar. It says 37. And that basically means 8 plus 14 is 22. And 22 plus 15 is 37. So you have 37 divided by 3. That is sufficient math work to kind of let us know that you didn't cheat. You at least understand how to find the average. Okay. Do the same thing for this one. 10, 14, 5. I'm going to go a little faster here. You've done this a couple of times. 10, 14, 15. And stat, calc, one of our stats. So summation is 39. The average is 13. And that one doesn't have any decimal places. It's 13.00, but you can just write 13. That's still rounding to the nearest hundredth. So if you really want some zeros, you can add that there. And then this one you can just do on your own. You can put in your calculator, but 18, this one's 33 divided by 3. So this one is 11. Okay, for the set of means you found in exercise 1, find the mean and standard deviation to the nearest hundredth. Okay, so basically what they want us to do, I'm going to use a highlighter because this might make more sense. These numbers, we're going to find the mean of them and then the standard deviation. So now I'm taking the 4 numbers, so if this makes sense, given these numbers, go ahead and find the mean and the standard deviation of these numbers. So let's go ahead and do that. Stat. So the hard part in my calculator here, I can't show you like the clicking and the buttons. So I say it out loud. Edit. Go to the top of your list. Press clear, which is near the down key. Enter. 10.67, 11, 12.33, and 13. Stat, calc, one of our stats, and press enter. There, my average is 11.75, and my standard deviation is 0.95. Oops, this one should have been a sample. Okay, so those are our answers. And then it tells us, get another color here, let's do dark color like purple. What are the mean and standard deviation of the original set? So now they want us to look at, for 3, they want us to look at these numbers right here, okay? So if I write those numbers down, 8, 10, 14, and 15. And there is a reason for this formula, but it's not just let's just do a bunch of stuff from the past, which is good for us. So we still want a mean and that's a mean population. That symbol there is mu, which we're going to review later. And this symbol, this one should have been an S. But anyways, let's put in those numbers. Stat cal. Oh, see, I have to go through it. Stat edit. Go to the top of the list. Press clear. 11.75. What am I doing? Come on. Wrong numbers, guys. I need to drink another sip of my coffee. Delete. There we go. Okay, my numbers are 8, 10. This is the original numbers from the top of the problem, 14 and 15. Stat, calc, one of our stats. And my numbers are 11.75 and 2.86. So that would be 11.75 and 2.86. I'm going to give you guys an analogy, and this will kind of hopefully make sense because it's like super real statistics. Let's just say this is our school. Let's just say this is the CVA school. This represents all the students in the CVA school. And, you know, there's not just 4 students in CVA. Let's just say there's like, I don't know, 400 students, teachers and staff, and supporting staff. And basically, you know, we can't test everyone for COVID because it would just cost too much and take too much time. Let's just say no one can enter the building. Let's say that's a real school, not a virtual school. And we want to make sure everyone's safe. So we have to test everyone every single day. Well, this would take too long, right? The lines would be long and it would be really expensive. So you can just take small samples. Let's just say we just take every 3 persons, right? And then we get their samples, right? They're in blue, green, red, and black. And this will kind of inform me about some data, right? And if you look at it, if you actually could take the population, if you can test everyone for COVID every single day, maybe our numbers look like this on the second list. So I'm going to call this one the sample, and I'm going to call this one about the whole population, because we actually found the whole population in question number 3. Well, if you notice something, the average was pretty much the same. And let me draw a picture here of our normal curve. This is actually the center, right? That's the center. That's what the 11.75 represents. And if you find something really interesting, the variation, the standard deviation in our sample, because we took so many other smaller samples, was small, but our variation or spread for the whole population was big, okay? This will make sense when we go over to the launch. So let's go over to the launch over here. And I want to talk about some notation. Like we said, it's not always feasible. It's not always a good idea, or maybe it's too expensive for us to always figure out what the population. So the first box over here, we're going to call is the population is a review is all. And when you get numbers from the whole population, that's called the parameter. You're getting parameter. Parameter. And where did my colors go? And we're focused on the mean. You're not a mean person. Remember, that just means the average. Standard deviation. Standard deviation, which is a measure of spread, and your proportion, which just is a fraction, right? Part over whole. Okay, so the symbol or notation for the parameter for the mean is this symbol. Let me see if I can get in really close. It's like a weird U, so long line, and then you draw your U. Notice how that line does not go all the way down. And it is a Greek letter, and they just call it mu. Mu. I think there's a Pokemon like that. Some of my kids do. Okay. And then for the under parameters for standard deviation, you have this long tail. It's an O. And then you draw a little tail on the top there. And this one's called sigma. Sigma. So if we were taking all the data from the whole school, we are basically taking it's called a parameter. And then the last one, the proportion, is just P. Okay. Let's change it to my purple. Okay, so you're like, we can't take a sample of every single person entering CVA. That would take too long and too expensive every day. Not practical. So we can just take something called a sample. You know, if you've ever been at Costco, a sample is just, you know, taking a sample of what you're packaging, of what you're buying, just a little bit. So I'm going to call this sum, right? Some of the students at CVA would be, or adults and teachers would be tested. So when you take a sample or some of it, the information you're getting for them is called a statistic. A statistic. And remember, we kind of talked about this before. Population, parameter, sample, you get a statistic there, right? Okay. And for statistics, this one we get, and you actually see in your calculator, which means your calculator actually is not, it's a tool, but it's not super accurate. So when you only have a sample, this is called a, how do we pronounce this one? This one we call X bar. It's an X, and you just put a bar. My X there just had a little tail. That doesn't matter. Just draw an X and put a bar over it. And then the standard deviation is just it's just an S. Okay, this one's kind of funny. We're having issues at my home site, but a proportion is the same thing with a P, but to show that it's a sample, we put a hat on it. And we actually call this P hat. Not fat, P hat. And so that is our notation. Okay? All right. I'm going to show you guys a visual about all this. I know it's just a bunch of statistical information, but it'll make sense when we talk about candy, because everybody loves candy. So I have some Reese's Pieces here. And this is a Reese's Pieces machine. And you might be wondering, in this Reese's Pieces machine, what percentage of the candy is yellow, red, and orange? Well, in this activity, you have all of the candy in the machine, and we can play kind of like Candy God and determine the probability of orange. So let's just say I set it to be 50%. Remember, a percentage turned into a decimal is 0.5. So I'm telling you, even though what you see in this picture of that half of the candy is orange, okay? And let's just say you get to put in a nickel or quarter in there, and you get to determine how many pieces of candy are coming out and how many kind of like quarters you have. Okay, so let's just do this. And I'm going to show the proportion of orange, okay? All right, so here goes the machine. You put in a quarter, you got 5 pieces of candy, and you have 2 orange. So if you multiply that, 2 out of 5, that would give you 4 out of 10, and 4 out of 10 you multiply by 10, it would be 40 out of 100, so that gives you 40%, okay? And so what they did is they took this 0.4 and they put it here on our dot plot. Okay, that's kind of gypped, right? We were supposed to get 50% orange, and this one only showed me 40%, so let's do it again. Uh-oh! The next time I put in the quarter, out of 5 pieces of candy, I got 4. So that's 4 out of 5, which is 80%. That's a lot higher than they told me, 50%. So if I keep drawing these, whoa! I love orange Reese's Pieces. So I got 4 out of 5, which is 80% again. There's another dot. And you can keep doing this. This one got me 3 out of 5, which is 60%. Wow, this machine. Wow, we're getting so lucky. We're getting all the orange pieces, which I love. Uh-oh. I'm not happy. This is 2 out of 5. This is lower than what they told me they were going to do. And if I just keep drawing lots and lots of candy, I'm going to shut off the animations now so I can do this a lot faster, right? So every time I'm pressing draw samples, I'm putting in the quarter, I'm getting 5 pieces of candy, it counts it, and it's just graphing it. And you would expect that at 0.50, right here in the middle, guys, we would have more of our candies. Does this make sense? Let's try this again. Let's do, let's try 10 pieces. Let me reset this thing. Okay, let's do 10 pieces of candy. Okay, the first time I got 5 out of 10. This one I got 2 out of 10, which is 20%. This one I got 5 candies, so that's 50%. That's what I expected, right? And keep doing this. Doesn't matter what you set this to be. That one got 4. Whoa, that one got 7 out of 10. That was 70%. I'll shut off the animations so I can go faster, and I can just keep drawing candy, right? And so you might think like, whoa, look at ours. Not just the number, we were getting 3s and you change this to proportions. We're getting 30% when it's supposed to be 50%. So this is skewed, right? This is skewed right. All the data is to the left, and then my tail over here is to the right. There's not much over here to the right. So let's keep drawing. Oh man, this thing is not pulling out my orange candies. What's going on, guys? But as you keep taking more and more, you'll notice something. What do you guys notice? Oh, it caught up. Okay, let's do now 10 samples at a time. What's happening now? As I keep taking more and more, putting more quarters in, getting more candy. Let's go crazy. Let's do 100 now. Wow, those dots even turn into lines now because they're putting so much data in there. It kind of looks now what? It looks approximately normal. So as you increase your sample size, and this should make sense because I'm basically draining. You're like, how much candy's in there? You're basically, when you're drawing it, so much samples. You know, we've taken here. Let's go crazy again. I don't know. Get a couple of zeros there. That one just drew like 10,000 quarters or 100,000 quarters. The point is, as you increase the sample size, your data becomes approximately normal. And that would make sense because if you kind of basically are taking all of the candy out, you're like, let me see all the candy in here. This will kind of tell you what's happening. Now it says the positive experience index score is the mean or average of the measures of positive responses. Positive responses are fill in blank to questions asked of adults in 140 countries. Higher scores mean or explained by that they have positive emotions, are more pervasive or more prevalent or happens more in these countries. These scores strongly relate to people's perceptions about living standards and personal freedoms and the presence of social networks or the ability to take care of yourself, like medical, health, police. Paraguay. Paraguay had the highest, so these are the fill in the blanks, had the highest positive experience index of an 84, with a margin of error of 3.5 at 95% confidence. The population estimate, margin of error, and confidence level are determined from the sample size. So the big idea here is, think about this. Did they ask everyone in Paraguay? The answer is no. They just took a sample. And just like we took from the candy machine, if you take lots and lots of samples, You're going to make some mistakes. So this is saying you can go plus or minus 3.5, but because we do so many samples, we have this confidence level of 95%, which is pretty good. All right, so I want to talk about this candy machine because the candy machine is like a big visual for us. So let's go back to this candy machine. And in the candy machine analogy of Reese's Pieces, which one represented the population? All of the candy in the machine, the candy coming out, or the kind of histogram bar graph at the bottom? Well, the machine here represents the, let's call this distribution of the population. Distribution of the population. I'm going to put population in all caps because basically this represents all the candy, right? You're like, I don't know how many pieces of candy. It's an infinite piece. All the pieces come out. Okay, which one represents a sample of our candy? Is it the graph below, or is it the candy coming out? Well, the candy coming out, that is our sample. So I'm going to call this the distribution of the, I'm going to put in all caps, sample. That's our sample, right? I'm not getting all of the candy at once, just like put 1/4 and turn it. And then therefore, the last one below, this here, represents the distribution of the sample proportion. I'm going to put that in all caps. And that's kind of like what we did in the warm-up there. Just strictly with numbers, right? Took 3 numbers, got some data, and then we got those 4 possibilities, and we just found their data. Well, that's like kind of like this graph here in green. All right. Let's go down now to 8.51, finding the maximum error of the estimate. Number 1, the data from a used sample can be used to make inferences about the corresponding population. This is called inferential statistics. The sample statistics is calculated and used to estimate the population mean, right? Whatever candy comes out, it can tell us what's actually in the machine. We're making an inference or a conclusion about what's inside the machine. There is variation between the samples of the sample population, right? What was coming out of the candy machine. However, which means that the sample statistics will often not be equal to the corresponding population parameter. Like, right, they said half were going to be orange, and was it always half? No, the answer is no. And this is called a sampling error. Sampling error is due to randomness, and it does not include bias or other errors that may occur when obtaining the sample. And as the sample size increases, the size of the sampling error will decrease because the sample increasingly represents the larger population. The standard error, I'm trying to find dark colors. The standard error of the mean, which is sigma, and then below is an x, is equal to sigma, so the tail, over the square root of n. So let's make sure we understand that part. This is the population standard deviation. And the n there this is the sample size. And if we need it, that's fine. So we just filled it out there. I did in purple. So we said that where sigma is the standard deviation, we don't have it in there, but x bar is the sample mean, and the sample size is n. Continue on. A confidence interval is an estimate of the population parameter using a sample statistic, stated as a range with a specific degree of certainty, and the three most common degrees of certainty and their corresponding z-values called critical values are given. So in this chart, go ahead and fill it out. 90% has a z-value of 1.645. So if you actually look up 0.90 on our table from our previous lessons, you'll get the number 1.645. We also have 95 has a z-value of 1.960, and a 99% certainty has a z-score of 2.576. Let's just use the highlighter going over here. This is those values. We're going to use those. Okay. The confidence interval for a sample mean is, x bar is equal to x bar plus e. And you might be asking, what is e? Well, e is the maximum error of the estimate between the population parameter and its actual value. The maximum error of the estimate is also called the margin of error. Margin of error, let's write that. It's equal to the margin of error. And we basically have this formula for the margin of error. E, which is the margin of error or maximum error, is equal to z, which is a z-value from over here, times s over the square root of n. What do these all mean? So this is your z-value, and it comes from your confidence level. So if I said you have a confidence level of 99%, then you would use 2.576. S represents the standard deviation of a sample. So sample standard deviation. And the N is the sample size. Like how many people, how many pieces of candy. And what we're doing here is you might want to check for something called these conditions. N is greater than or equal to 30. You want to make sure that you're getting one larger than 30. All right, let's move on to our example about chess, which I'm the chess club advisor. All right, let's go over this chess problem. Chess, a poll of 315 randomly selected members of an online chess club showed that they spend an average of 4.6 hours a week playing chess. With a standard deviation of 1.2 hours, use a 90% confidence interval to find the maximum error of the estimate for the time spent playing chess. All right, the first thing I'm going to do is just take all the variables that we just read. So I have 315, so I think that is the total number of people there. And then it tells me it takes an average of 4.6 hours. So I would read that as the mean. Not sure if we're going to need that, but I'm just highlighting it. And then I have the standard deviation here. So S equals 1.2 hours. And then this confidence interval, we're going to have to go back and use the chart on the previous page to find the maximum error. And then this one right here, maximum error of the estimate, that is just the E. What is E? So I broke this down into some steps. Step number 1, find the Z value. So with a 90% confidence interval, we're going to have to use the Z-score of 1.645. So a 90% is equal to Z equals 1.645. Okay, so let's go ahead and box that. And then let's get our formula from the previous one. Find the maximum error of estimate. Well, that's just E, and you might just want to use the previous formula. Well, you can do my favorite, magic. Look at that. Just have to do a little bit of erasing there. Okay. Okay, so the Z-score comes from here. So right there, I'm going to write 1.645. And then the S is the standard deviation. So that's why I'm going to write 1.2. And then the N value was 315. And if you didn't know, in your fractions, how do you make 1.645 a fraction? And you basically put it over 1. And that's why I'm drawing that fraction line. It's really 1.645 times 1.2 divided by the square root of 315. Let me go ahead and take a screenshot with my phone. Okay, let's go ahead and put that in our calculator. Press clear, and then I'm going to type in 2 sets of parentheses. And the reason I'm doing that is to show that we're in the numerator. I didn't have to put a multiplication sign, remember, because when they're next to each other and there's no plus or minus, then it's multiplication. And I'm going to divide that by the square root. Okay, so square root is in there, in the corner there above the 7, and it's an orange. So I'm going to have to press second x squared. Second x squared. And then you see how mine's red? You're going to have to press the right key to get out and then close your parentheses, okay? And this would give me a margin of error of 0.12. Sorry, 0.11. And then we can write a sentence to kind of help us understand what is happening here. We can say with 90% confidence, can't spell confidence confidently, confidence, that the mean time a chess club member plays per week within 0.11, that's from when we got above, hours of the sample mean time. Okay, let's put it in context and then you can try a problem. So basically, people that we interview for the chess club are playing 4.6 hours a week, right? We interviewed 315 people, and although there's a standard deviation of 1.2 hours, I am 90% confident that people are playing And then my margin of error, the maximum error of this estimate is only 0.11. Okay, let's go down here. Go ahead, and it says in questions 1, 2, and 3, skip one problem below. So go ahead and let's just say you want to skip number 2, just put a big X through it, and you have more space to do questions 1 and 3. And then when you're ready, you can just press play to check your answer, or you can do it step by step with me as I go through all of the problems, but you only need to do 2. Okay, let's go over these problems here. Homework. A pool of 225 selected high school students. So again, I'm going to start annotating or marking up the text. I have n equals 225. High school students show that they spend an average of 2.75 hours per night doing homework with a standard deviation. So I have S for standard deviation, 1.5 hours. I have a 90% confidence interval to find the maximum error of the estimate for the time spent doing homework. Remember, the maximum error of the estimate is just E. We can do what we did above in those 2 steps. So the first step, step 1, is what's our z-score? Well, the 90% confidence interval is a z-score of 1.645. 1.645. Okay, step 2 is really what is our E value. And remember, E equals Z times the S divided by the square root of N. So let's just go ahead and some people say plug and chug. Well, it's really substitute and evaluate. So our E value is equal to my Z-score was here. Let's go ahead and write that in. 1.645 times our S value. Our S value was 1.5. So I'm going to put that there. And then my N value was up here, 225. Now, don't forget to write that one in what? The square root. What did I just say? Short-term memory, 225. Okay, let's go ahead and put that in our calculator. Now, here's a trick. This problem looks very similar to the one we just did. So I can repeat everything. To do that, I'm going to press second enter. Second, the orange button, and then the bottom right. And what it does is the orange word says entry. You're basically repeating the entry or copy and pasting. Second, enter there. We already had a 9% confidence interval that had a z-score of 1.645, so I don't have to change that one. This one was 1.5, and I believe this was 225. Go out and just press enter. And our answer is 0.1645. Now, it doesn't tell us how to round, but in the previous problem, we rounded to the nearest hundredth, so I'll just do, say, 0.16. E equals 0.16. And this sentence helps you understand what is happening. So let's just copy that sentence. We can say, with 90% confidence, the mean time a student does homework per week. I'm abbreviating, go faster. Within 0.16 hours of the sample mean time. Guess we could just copy and paste that. But the big idea is that we're getting, because you're drawing the data from these random students, we have 90% confidence, pretty confident that, you know, when we draw a sample from them, they're only 0.16 hours away from everyone else. All right, let's try number 2. Number 2 here is telling us athletes, a pool of 350 randomly selected athletes, so there's my n value, 350, show that they spend an average of 10.25 hours a week. So the mean here, the average, I don't need. Let me say that again. The average we don't need for our to find our maximum error of estimate. But I'm still highlighting the numbers are giving us. S equals 2.3 and a 95% confidence interval find the maximum error. Remember, the maximum error of estimate is just your E. We're trying to find E. So the first thing we're going to do is, what's our Z-score? And this time, a 95% confidence interval basically tells us that Z is 1.960. 1.960. And to find our margin of error, our maximum, I know we're saying maximum error of estimate, that's just E equals Z times S over the square root of N. And so my Z is 1.96 times, remember that you're making a Z a fraction, so it's just Z times S. So my S value is 2.3. And the N value is up here at 350. So that goes inside 2.3 and 350. So again, the shortcut, second enter, you can just repeat what you had. And I have to change the Z-score. 960, you can just type over it. And then our standard deviation was 2.3, and we had how many people do we have? 350. Press right, and I get 0.24. E equals 0.24. And then I can just use some magic. I don't want to get in the way of that one. And watch this. Let's see if we can do something. Boop! Oh, change it to green. Nice. Okay, now we can just erase the parts that we were saying. We have a 95% confidence that the meantime a athlete what are they doing? Practices per week with N, what was our number? 0.24. 0.24 hours of the sample mean time. And our last one, of course, pets. Pets, a pool of 470 selected pet owners, so N equals 470, show that they have an average of 1.9 pets per household within a standard deviation of 0.5 pets. So again, we don't need that, but I'm just going to write X bar equals 1.9. And then a standard deviation of S equals 0.5. Okay, we have a 99% confidence interval to find the maximum error of the estimate. Okay, so the maximum error is the capital E. So just like the practice problem above, the first thing we're going to find is the Z. So a 99% confidence interval gives me that Z is equal to, just go back up to this chart, And 2.576. 2.576. Okay, the second thing is I want to get E, which is the maximum error of the estimate, or the margin of error. So I have E equals the Z times the standard deviation over the square root of n. And we were saying that to make Z a fraction is just over 1. So it's just really Z times S over the square root of n. Okay, let's do this color coding here to help you. Our Z score comes from right here. So let's write that in. E equals 2.576. Okay, and then our S value is our standard deviation. So standard deviation 0.5. And really that's just over our N value, which is 470. Okay, let's go over here. Let's just do this for the first time, and I do two sets of parentheses to kind of show the fraction. I'm going to try something. This student told me a long time ago. So alpha y equals. Alpha y equals. You'll see this says fraction in green there, so let's just try it. Oh. Let's try it. Ooh, do you see what it did? It made a fraction for me. So again, that was alpha y equals. Alpha y equals. Good job, student of the past. Okay. So our Z-score is 2.576, 2.5576, parentheses, and then our standard deviation in our problem is 0.5. Now to go downstairs, you just press down, and we're going to have to get the square root button. So that would be second x squared, second x squared, and then that would be 470. Now it has a red on the screen, so just click out to the right and you press right again. So I'm out there and just press enter, and I get 0.06. 0.06. Let's do some magic over here. Magic. What color do you guys like? Let's do black. Boom. We can say with 99% confidence. The meantime, what are we talking about? I mean, meantime, the mean, whoops, the mean number of pets per, not week, household with, what was our number? 0.06. 0.06 pets of the sample mean number of pets. Number of pets. Okay, so that is using 8 point blah blah blah. What number is this? 8.51. Find the maximum error of the estimate. Let's move on to 8.52, the estimate of a population mean. All right, to estimate, the key concept here is estimating the population mean. And so if you think about the symbols we need to find the mean of the random sample. And this is going to be x bar. This one is mu, remember, because that's the population. And the one I just did is from a sample. Step 2, we need to determine the degree of certainty. So let's look in the chart. Number 3, find the error of estimate. What letter did we just find previously? That is our E. And then estimate the mean population, which is mu, by finding the interval. Okay. This is 2 problems here. And it's not an order pair, it's just a range, like interval notation. Okay? All right, let's go ahead and try this problem. Web traffic. A survey of 50 students at East High School asked how many websites they visit at least 3 times per day. The sample mean is 8.61 and the sample standard deviation is 2.6. Use a 95% confidence interval to estimate the mean for the population of East High School students. Okay, let's just get some information that we need. I have n equals 50 here. They visit them 3 times a day. Okay, not important. The sample mean, this is important. This is x bar equals 8.61. That's important. And the sample standard deviation, that is important. S equals 2.6. And then I have a 95% confidence interval. Okay, let's do a couple of things. The first thing I want to do is I want to calculate E. So let's see what we got so far. Do we have step 1? Yes. Now, degree of certainty. So a 95% confidence interval gives me a z-score of, look back at our chart, and our chart says 95% is 1.960. Okay, so we got that. Now I need to determine E. So E equals z times s over the square root of n. And remember we talked about just make that fraction bar really long. Okay, so let's just calculate E here. E equals our z-score goes right there, which was 1.960. And then our standard deviation, which was 2.6. And then we're going to get that by an n value of 50. Okay, so let's go ahead and put that into our calculators. Let's just not cheat, but just use our technology. Second enter. And I'm just going to go up here and change the confidence interval z-score, which was 1.960. And then over here, this one was 2.6. Close parentheses and go downstairs, and then I think the score was 50. Okay, so I have an extra number. You just press delete, which is next to the left key. I can't undo. Okay, second enter. Sure, we could still do that. That's close to actually what we had, right? Delete that one, and this number was 2.6. And 1.9, great. Okay, awesome. 0.72. E equals 0.72. Okay, let's review what we've done. Step 1, we found x bar from the information above. Yes. Determine the degree of certainty. Yes. 95% gives me z, 1.960. We found E. Estimate the mean of the population by finding this interval. Okay, so hey guys, magic. This is the formula that I need. Boom. Okay, so step 2, let's just find the interval. Okay, so x bar, here's a good thing. X bar is right there. It's the same number. We're going to do it twice. Eight 8.61. Okay, then E, we just found E. Random colors here. Let's do purple. Do it again. Purple. 0.7. Well, that was dark. 0.72. E 0.72. E 0.72. So I'm going to subtract 1 and then add 1. And when you put that in your calculators, you're going to get 7.89 and 9.33. Okay, so that's kind of like our answer. Box it, and then I'm going to write this sentence to help you understand. What kind of confidence interval? At a 95%. Again, feel free to copy and paste this sentence frame. Now we're using this to estimate what the population mean. Is 7.89 from above. And population mean is this score. So now I'm just using an inequality here to represent my range. Therefore, we are how confident? 95% confident that the number of website users or students visit at least 3 times a day is between 7.89 and 9.33. All right, directions in questions 4, 5, and 6. Skip 1 problem below. Go ahead and try those on your own. We're basically using the same information we did in 8.51 to calculate E, and then now you're just using the interval. All right, let's try the freight problem. I have a sample package of 200 packages at a shipping company is weighed. The sample mean, so x bar equals 5.8 pounds, and the sample standard deviation s equals 2.7. Use a 90% confidence interval. So what's our E value? Well, I'm going to have to calculate the z first. So a 90% confidence interval gives me a z-score of, look at your chart above, 1.645. E is equal to the z times s all over the square root of n. So let's go and plug a chug away, substitute. All right, our z-score is 1.645. And then our S value is 2.7. See how that color coding helps? Helps you kind of visualize and see what's happening. 2.7 all over the square root of, we need an n value, which is 200. And this will give us a an e value. Okay, so second enter, we had a blah 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 90% confidence interval, and a 90% confidence interval will give me, I'm looking for my chart, where my chart, blah blah blah, my chart at 90%, 1.645, and then our standard deviation was 2.7, and then our n value was 200. Go right key, and then press enter, press it too many times, we got 0.31. Okay, then question number 2 says, what is our mean? And we get this, we can't confidently say what it is, so we can give a range, okay? So our range is x bar minus the e and x bar plus the e. And our x bar is 5.8. Don't need that one. It's a plus, minus, and our e values from what we just found. Let's do a different color. Blah. Why is it so thick? Why does it do that? 0.31. 0.31. Okay, so 5.8 minus 0.31 will give me 5.49 and 6.11. So again, we don't know what the total, the population size of those packages are, but we are 90%. Let's write that sentence frame. Guys, this is what I'm telling you about. Technology is really helpful for me. Instead of writing all that out, let's see. Magic. Let's do some erasing at a, 90% confidence interval. The population mean is, what was our answer? Five point 49 to 611. Therefore, with 90%, confident that the number of weight of packages the weight of packages is between 5.49 and 6.11. Pretty confident, right? We don't know the exact weight, but we can be pretty confident. All right, let's try airlines. A survey of 700 airline passengers. So let's use a different color. N equals 700. Ask about satisfaction. The passengers must rate the airline on a scale of 1 to 10. Okay, confusing. That doesn't matter. Where 1 is satisfied and 10 is extremely satisfied. 1 is not satisfied, 10 is extremely satisfied. The sample mean, so that would be our X bar, is 5.5. Standard deviation is 1.5 and a 99% confidence interval. So first thing I'm going to do is find E, but to find E, I need to find my 99% confidence interval gives me a z-score. Let's look back at my chart up here. Candy, Reese's Pieces. 2.576. 2.576. And then to find the E value, it just means E equals Z times S over N. Okay, our z-score, we just found that, goes here. Our standard deviation, 0.5. And our N value is 700. Second enter. Is that nice? 2.576. Let me double check. Even I have to reference them. I have not memorized them. Yes, that was correct. And then our standard deviation was blah, 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 1.5. And we had 700. Oof. 0.15. 0.15. Okay, so now we're going to figure out what the population mean is with our confidence interval. To do that, I'm going to have what we call the, what do we call this? Estimating a population mean, which is X bar minus E and X bar plus E. Okay, where do I get X bar? This number comes from reading right there, 5.5. E is 0.15. Let's write that a little bit nicer, Mr. Ing. And then when you do that, our two numbers are going to be 5.35 and 5.65. And check this out. If I, let's see, no, it's still saved. Ah, it's okay. Come back here. Do it again. Do it again. Okay, at least we have a starting point. At a 99%, confidence interval, the population mean is between 5.35 and 5.65. Therefore, we are 99% confident that the, what are we talking about in this problem? That the rating of the airline is between 5.35 and 5.65. Okay? All right. Before I lose it, let's try to paste that over here. What color do we like? Blue? All right, let's do all blue. And let's just do the problem. All right. I just want to use that for later. Okay, question number 6. Credit hours. Sample of 650, n equals 650. College students are surveyed about the number of credit hours they are taking this semester. Credit hours is basically kind of like in high school, you guys get 5 credits per semester. And in college or semester-long classes, you get 3 credits hours for a semester. It says the sample, so x bar equals 14.75, and the sample standard deviation is 2.25. 95% confidence interval, so let's go ahead and do our work here. So a 95% confidence interval gives me a z-score of 1.960. And then E equals Z times S over square root of N. Okay, so the Z is 1.960. What is our standard deviation? 2.25. And then a square root of n, which is a lot of people, 650. All right, so if I take pictures, I don't forget the numbers, boom, come over here. Let's do it all at the same time again. 1.960, 2.25. Okay, I'm going to close my parentheses to show that this is the numerator divided by square root, second x squared. 650, it says red there, so push right. Close the parentheses and then press enter. 0.17. 0.17. And then I need to calculate a range in which the population mean would be. So x bar minus E, x bar plus E. And our x bar is 1475. So 1475. Our E value .17. So if I put in my calculator 14.75 minus 0.17, I will get 14.58 to 14.92. Okay, so that means at a 95% interval, erase all the things I'm not going to need in here. At a 95% confidence interval, the population mean is 14.58 to 14.92. Therefore, we are 95% confident that the number of credits hours taken by college students is between 14.58 and 14.92. Okay, so that was 8.52. Let's move on to the next one. All right, 8.53, estimate a population proportion. You can also use confidence intervals to estimate a population proportion. And that is annotated by a P, or italicized P. Just a quick review, a proportion is just a fraction, which is the number of members in the population with a particular characteristic divided by the total number of members in the population. Like the population mean, the population proportion is often difficult to determine. Instead, the sample proportion, so here I'm going to draw a P. Let's see if I can do this. We did this before, and you draw a hat on it. P hat is used to estimate P. So again, let's just say at Savannah or CVA, I can't get everybody. I can only, maybe I just do Mr. Ng's class and interview them. That sample tells me about the population. A sample proportion is the proportion of successes in a sample. Success, underline that, success. P hat means success. The proportion of failures, use a different color, underline it, failures, is represented by Q hat, because Q has a hat. The proportion of successes, P hat, is given by P hat is equal to X divided by N. X divided by N, where X is the number of successes and N is the sample size. Basically, it's making it a fraction. That's what we talked about, number of trials. Failure, the proportion of failure, which is Q hat, is Q hat equals 1 minus, pay attention, P hat. Okay, why is that case? Let me give you my little shortcut here, okay? Rain plus no rain equals 1. Okay, why did I say that? Because the probability that it rains plus the probability that it's no rain, Q hat, equals 1. And if you just move the P over, subtracting P hat from both sides using your algebra skills, you get Q hat. Let me show you. One minus P hat. Okay? So think about, that's the best one. Rain plus no rain equals 100%, right? I look outside, it's really blue right now, so the chance of rain is 0. 0 plus 100% chance there's no rain equals 100% or 1. Okay, number 6. Like the sample mean, P hat is an estimate and will likely not equal the population proportion. Therefore, a confidence interval using P hat and a maximum error of estimate E, we've talked about E before, is used to find a range of values within which P likely falls. Number 7. Here's the formula. The maximum error of the estimate E of a population proportion is given by E equals, oh, we've done this before, Z, seen that before. Okay, this one's different. Big square root P hat times Q hat divided by N. Okay. And we've talked about all those before. And I have some steps below. All right, steps to estimate the population proportion. Finish number 8. Okay, number 1, find the proportions of success and failure. Okay, so what is that? That's P hat and Q hat. Remember, you add those together and it equals what? 1. Step 2, find the sample size. What letter is that? That is letter N. Number 3, identify the corresponding Z value. So if we get a confidence interval, we can use our chart to find that Z equals some kind of number. Does that make sense? Number 4, find the maximum error of the estimate E. Well, we've already done that. E equals Z times S divided by the square root of N. But this one, sorry, that estimate though, and then we can still use that to get P hat. Number 5, the confidence interval of the population proportion is P hat is plus or minus E. So how is that linked to what we did previously? We kind of did a range. We did something like this. You guys remember that? That's pretty much the same thing, because I just want to show you guys mathematically. It comes, last time you guys saw that was from the quadratic formula. There's a plus or minus. It's actually 2 problems. Okay? All right, let's try that with the lunch period. This is in your textbooks, if you wanted to know, on page 406, example number 3. A survey of 150 students. So I'm going to stop, and as I read, I'm going to annotate. N equals 150. At West High School, ask them if they agree with the administration's plan to split the lunch period in 3 different periods, with 72 response saying they agree. So this is kind of like, you like it, right? So 72, this is my number of successes, X, okay? Use a 90% confidence interval to estimate the population proportion of all, so now they're telling me, of all 1,334. Okay, so we didn't talk about this before, but I'm just going to tell you now. I did 2 types of n's here. I have a lowercase n, which is my sample size, and capital N represents the population. Okay? Let's see if I can help you remember that. Sample and population. Watch. So sample, lowercase, and population, capital N. because that tells you everything. Okay, so what do we need to know? We need to know what success is. Success in this problem, let's just define it. So step number 1, p hat is x over n. So that is the number of people who agree, 72. Let's split up your whole lunch into 3 lunch periods, and our total there on our survey, lowercase n, is 150. Okay, so p hat is going to be 48%, 0.48. Okay, watch this. Q hat is basically the complementary, we call it. So 150 minus 72 equals 78. So p hat is really 78 over 150, because those are the people who are saying, nah, I'm not in agreement. And if you do the math, that would be 0.52. Okay, so you have p hat and we have q hat. Okay, that was step number 1. Okay, step number 2, we already know what the sample size is. Step number 2 is the sample size is 150. Okay, basically if you think about what we're doing, we're just getting all of our variables ready to put into the formula. That's all we're doing. All right, step 3, our confidence interval of 90% basically gives us a z-score. Look back at your chart. Looking back at my chart, come to me chart. Uh, 1.645. Okay, step 4. Find the maximum error of the estimate. Now, before we do this, we need to make sure that our proportion have a large enough sample size. And in order to do this, we're going to have to do a formula. So I don't have this, but I could do step number 6. I don't know, let's call it step 0. I think that's better. Step 0, let's write that. Step 0, I'm going to call it check conditions. Check conditions. And really, we should have n p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. We're making sure that we have the right condition, so I'm going to do that up here. Where am I going to put this? Down here. Kind of out of order. So step 0, I have n times p hat is greater than or equal to 5, and n times q hat is greater than or equal to 5. Okay, so our sample size was 125, and our p hat, so let me color code it. Let's go back. N is 150. Where did I get 125 from? It is 150. That is correct. Why did I write 125? I don't know, Mr. Ing. Now I'm just talking to myself. Okay. 150. And then my p hat is 0.48. And is that greater than or equal to 5? Put that into my calculator right here. 150 times 0.48. And that gives me 72. So 72 is greater than 5. So that's yes. Okay, q hat, 0.52, greater than or equal to 5. 150 times 0.52. That gives me 78. 78 is greater than or equal to 5, and that is also true. So step 0, we've met these conditions. Step 0 is check conditions. Okay, so we did step 0, step 1, step 2, step 3. Step 4, we are now finding the maximum error of estimate. So E equals Z times the S over square root of N. Okay, so well, I want us to notice that the formula we had above here, I don't have an S. So I'm going to use the one in the yellow box. Well, duh, that shouldn't have made sense. Let's try that again. So over here, you need square root of p hat q hat over n. Let's write that. E equals Z times p hat times q hat over n. Okay, our Z is 1.645. Okay, so same thing with this thing. Don't be scared of it. P hat is over here. Oh, wasn't highlighted. Just throwing things around. 0.48. And Q hat is 0.52. And the N value, where'd you go? Come back. Our N value is 150. Okay, so take a picture, then I'll put in the calculator with you. All right, so bump, bump. Clear, I have 1.645 times parentheses. Okay, I'm going to do second x squared by 7. Then in here, I'm going to do parentheses to notate the numerator. 0.48 times 0.52. Close the parentheses, divided by 150. Out of there. And then I'm going to close the parentheses. Okay? That gives me a number of 0.07. E here represents 0.07. Okay, then step 5, the confidence interval of the population is, let's write that. Step 5, we are taking our p hat plus, you could be consistent with what we did previously. Let's just do minus first, doesn't matter. And p hat plus e. Okay? So, p was 0.48. And E was 0.07. That's a plus, that one's a minus, so I get 0.41 to 0.55. So, my sentence, this sentence is shorter, and feel free to use it again with what percent confidence? 90% confidence. The proportion of students agree with admin is between 41% to 55%. So not a big group is really really going well with the admin. Okay, directions. In question 7, 8, and 9, skip one problem below. So go ahead and cross off one of those. And if you want to do it with me step by step, press play. Or you can kind of fast forward to just check your answer, see if you're doing it correctly. Part-time job. A survey of 120 students. So there's my lowercase 120. At South Grove High School asked if they agree that high school students should have part-time jobs, with 93% of the response saying they agree. So there's my X, there's my success. Use a 90% confidence level to estimate the population proportion of all 1,532 South Grove High School students. Okay, so the first thing I'm going to do is my p-hat. P-hat equals x over n. And I have 93 over 120. So if I put that into my calculator, 93 divided by 120 gives me 0.775. Okay, that means q hat, you can just do 1 minus 0.775 equals 0.225. Because remember, if you add these two numbers together, it equals one number? 1. Rain plus no rain equals 1. Okay. Got that. Step 2, we need a sample size. I forgot. Step 0. Let me just write this down. X n equals 120. Let's do our friend who's a magic. I don't have to erase it. I can just do what? Ta-da! Whoops, I changed all the colors to black. Totally fine. Step 0. We need to check our conditions. So our conditions are n p hat greater than or equal to 5 and n q hat is greater than or equal to 5. Basically need to know their sample size is big enough. So n equals 120. P hat, try that again. P hat is 0.775 and our Q hat is 0.225. Let's write that in there. Do we not highlight this thing? I just want to know that these are greater than 5, and I already know they're going to be. I just have that feeling. $93, right? And are our conditions met? Yes. That's supposed to be yellow. Try that again. Is that conditions met? Yes. Yes. Boom. Okay. We got our n values, blah, blah, blah. Confidence interval z-score. Okay, let's get that. This one has a 90% confidence interval, so that basically means my z-score. Look at my chart, saved it on my phone. 90% equals 1.645. Okay, what do we need to do next? Find E. E equals z times the square root. Remember last time we didn't have the standard deviation, so now we basically have p hat q hat divided by n. Mathematically, it's the same formula. It's just that we don't have standard deviation, so you can take p hat times q hat, the square root of that. That doesn't make sense. That's okay. All right, try that again. I wanted yellow. This number, whack, E equals 1.645. P hat q hat and divided by n. Take a picture of this. Let's do that together. Might be a tricky one for you. All right. 1.645 times second x squared parentheses 0.775. Did you notice that p hat times q hat, or the blue plus green I had on the previous page, are equal to 1? .06. And then we're just going to do the step 5, which is p hat minus the e and p hat plus the e. So the p hat is 0.775. Our e value we just found 0.06. No, it's a plus. So then my range, 0.775 minus 0.06 gives me 0.715. 0.775 plus 0.06, 0.835. Remember, as we talk about percents, you just, a decimal to a percent, you just multiply it by 100, so that would be 71.5%. Let's go to my friend who's a magic. And with 90% confidence, the proportion of students that agree students that have should have part-time jobs. Pretty high, right? You know, maybe you're working to support the family, or maybe you're just getting money for prom, or some students want to do like a senior trip. All right. A bus. A survey of 215 students at Landry High School asked if they ride the bus to school. With 46% of respondents say they do. Use a 95% confidence interval to estimate the population proportion for all 1,109 students. Step 0, let's check for those conditions. N times p hat greater than or equal to 5, and n q hat greater than or equal to 5. Well, I need to get those from p hat. So p hat is x divided by n, which is our total of success, which is x, which is 46, and our n value, which is 215. And so if I put that into my calculator, 46 divided by 2.5. Okay, so I'm going to ask 0.214. So 215 minus 46 gives me 169. And 169, this is q hat, divided by 215 will give me 0.786. Because remember, those two numbers equal to 1. So I can take this number put it right here. Q hat, take that number, put it right here. N value, 215. And let's just fill it in here. 215.214. Is that greater than or equal to 5? Checking our conditions. 215 times 0.786. So 215 times 0.214 equals 46. That matches. 215 times 0.786. 168.99. Is that bigger than 5? Yes, it is. Good. Bam. Okay, 2. What is our n value? Our n value is already 215. Step 3, I need the confidence interval of 95%. So look back at the chart at the beginning of the class. And I'm going to erase you because I'm looking at my phone. I can't read my writing. That says a 5. Come on, Mr. Ring. 5. 95% is 1.96. Okay. Step 4, let's find our margin of error. P has a hat, Q has a hat, divided by N. And our Z score is 1.960. My P hat is blue. I did it again. I always do that one, huh? There, there, there. There, there, there. And so 0.214, 786. And our N value, we highlighted in yellow, that came from the 215 up here. Let's put that into my calculator. I'm taking a picture of my math work. Alright. Boom, boom. Oh, look at that. Looky, looky, looky. Second enter. Save myself some work, kind of. 960. P was 0.214. 0.786. Ooh. See the mistake here? 2 decimals, bad. Okay, I know what happened. Okay, so I'm missing a parentheses right here. So I'm going to press second delete. And it created that space. I'm putting a parentheses right there. Okay. And then divided by 215. And I'm going for the home run. And the home run is I'm putting my whole formula all at once. You could do 1.960 divided by or multiplied by some number. But the home run is let the calculator do all that. The only issue you're going to run into is your notation of you putting it into your calculator. That's why I'm using extra sets of parentheses. All right. 0.055. 0.055. 0.055. Okay, now we just need to do step, what do we call it? 5. So this would be P hat minus E, P hat plus E. And this would give you, P hat was in blue up here. .214. And our E, here, 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 here. And if you calculate those numbers, question number 8, blah, blah, blah. Put in the calculator, 0.214 minus 0.055 will give us 1.59 and 0.269. And let's go to our friend Magic. What color you guys like? How about purple? Okay, what do we got? With a 95% confidence, I know we're gonna write something in there, and that number is gonna change. At a 95 confidence, the proportion of students who ride the bus is between 15.9% and 26.9%. So at this particular school, not a lot of students are taking the bus. And question number 9, a field trip of 245 students, n equals 245, at Jackson High School. Ask them if they agree with the principal's decision to have students pack their lunches for a field trip. With 102 of the respondents, so that's our success, x equals 102 of the respondents saying they agree, use a 99% confidence interval. Okay, 0, we're going to check the conditions, but in order to do that, I'm going to have to figure out p hat. P hat is the success over n. And my x value there is 102, and the sample, pay attention, the sample, not the whole school, just the sample is 245. So p hat is equal to 102 divided by 245.42. Okay, so that means q hat is just 245 minus 102. Duh, I should have done it in my head. 143 over 245, and that'll be the complement. So 0.58. Okay, so Q equals 0.58 and P hat equals 0.42. So more people are against the idea for right now, what we can see. And that formula is N P hat greater than 5 and N Q hat greater than or equal to 5. So 0.42, highlight the wrong thing, 0.58, and we need how many students? 245. Did I not use green there? Okay. So 245 times 0.42, is that greater than or equal to 5? And then 245 times 0.58, and is that greater than or equal to 5? So 245 times 0.42 gives me 102.9 students. That is bigger than 5. Yes, 245 times 0.58, and that is bigger. So my conditions are met. Okay. Step 2 was the sample size, and we already had that n equals 245. Let's just color code that because we already said it was yellow. Okay, step number 3. I was gonna yell at myself. It's okay. It's okay. Mistakes happen. Our confidence interval in this problem is 99%. So a 99% confidence interval gives me a z-score of 2.576. Okay, 4 is getting my estimate. Margin of error, E equals Z times square root of P hat times Q hat all over square root of N. And we said that Z goes here. And 0.42, green from over here. It's running out of the house. You gotta cover it up. And then our N value, which is 245. Wrong color. 245. Okay, so 0.42, 0.58, and 245. Let's take a picture. Put it into the calculator. You want to see me do it all at once? Sure. 2.576 parentheses, close parentheses, open the parentheses down for the second part. And it's a big, my notation in the last problem, I realized that I didn't put a whole square root over everything. So second x squared, parentheses, so 0.42, 0.58. We're still inside the parentheses, divided by now the denominator, which is 245. And close parentheses, and that last parentheses is just showing that 2.56 times everything inside the radical sign, and 0.08. What I was trying to show you is, hold on, I'm gonna forget. Okay, so this here, hopefully you recognize it's the whole thing. And mathematically, I just want to show you this, that these are the same. Okay. All right, let's just finish this up. Let's do number 5. Number 5. P hat minus E. P hat plus E. So P hat is blue. 0.42. 0.42. And then minus plus, then E was 0.0. Highlight 0.08. And this question, number 9, then would give us 0.33. What? Let's see. .34 and 50. 0.50. And then if I take my magic, and I'm going to put it right there and turn it green. Okay. What do we got? So a 99% confidence interval. A 99% confidence, the proportion of who? Students who agree with the principal's plan is between 34% and 50%. Okay. 8.54, misleading population estimates. So let's make sure to steps to check misleading population estimates. The first thing I want you to do is verify that the NP hat is greater than or equal to the margin of error, and the NQ hat, oh, that's twice, is greater than the margin of error, or that's greater than or equal to, we used that number to be 5 before as well. And the second thing I want you to check is the confidence level. You know, there's only 3 numbers. What are our 3 numbers for our confidence intervals? It's only 90, 95, and the third one is 99%. And we also need to check the interval. All right, let's take a look at example here, polls. So, you know, the biggest use of statistics and population parameters is actually on voting day in November, voting for either Trump or Biden. And every year, you know, even local elections, the biggest thing is using statistics to estimate with confidence, do we have all the votes? Because they don't have all the votes all the time until the very end. A lobbying group that supports the passing of a ballot measures of a ballot measure releases a report based on a poll they performed. They claimed with a 90% confidence the proportion of people who will vote for the measure is 50%, but could be as low as 40% due to the margin of error of 5%. The sample size was 200. Identify any misleading representation in the data. All right, this is how I got p hat. P hat, if you add 5% to p hat, and you get, say, 50%, right? Because if you do p hat minus the margin of error of 5%, that's the margin of error, E, think of it as E. So if we subtract 5%, we should get 45%. We should get a range of 45 to 55. Does this make sense? Let me highlight those 2 numbers. So if I know that it's 45, it has to be 45%. And I'll tell you why. Because if I add 5, I get 50%, because that's the high. And if I subtract 5, I get 40% as the low. So p hat is, let's make this clear, p hat is 45. Well, if p hat is 45, that means q hat has to be 55, because they're complements to 1. So let's just check their conditions. 200 times 0.45 is 90, and that is greater than or equal to 5, and 200 times 0.55 is 110. So it does meet those conditions. Okay. Let's go on to step number 2 now. Examine the confidence level. 90% confidence level is acceptable because you only have 3 numbers, 90, 95, and 99. Okay, now this is where it goes wrong. And let me write this in writing so you can kind of see it. However, in instead of stating the population proportion is estimated to be 45% with a margin of error of 5%. But their mistake, so let me write this in red, kind of like bad. Well, red's not bad, but I'm just trying to they state the highest possible estimate for the population proportion to give the impression the candidate is likely to obtain 50% of the vote. So even to use the words, they're saying 50% is the high or the upper end of the possible range that he'll get. But that's not true. It's at 45%, and it can go up to as high as 50, but as low as 40. But they should have focused on the number 45 as their point of estimate. Okay, directions. In questions 10 and 11, skip one problem below. If you want to see me do it with you step by step, then go ahead and just press play. Okay, question number 10. An employee at a restaurant conducts a poll about the satisfaction with their lunch menu. The report claims with 80% confidence that the proportion of people who are satisfied with the lunch menu is between 85 and 90%, and the sample size was 15. Identify a misleading representation of the data. Okay, let's first talk about 80% confidence. What do you think? This confidence level is too low. What are the numbers? Should be 90, 95, and 99%. What else do you notice? Sample size. If n equals 15, let's do some math. If our sample size let's just say is 87.5. P hat is 87.5. And I got that number is because it's in between the middle. Does that make sense? Because you're kind of adding and subtracting. That's subtracting that direction. You're adding that direction from the point of estimate. Our sample proportion. So that's in between, 85 plus, let me explain that again. 85 plus 90 divided by 2 gives me 87.5. And if I take that number, n times p hat is greater than 5. N has to be, what did we say? 15 times 0.875. And is that greater than or equal to 5? Well, I get 13.125. It is greater than 5, but if I do the Q, So 15 people. And then 1 minus 0.875 equals Q would have to be 0.125. Is this greater than or equal to 5? So 15 times 0.125. This gives me 1.875, and this is what? False. It's not greater than 5. So there we can say our sample size is too small. Right? All right, question number 11. A recent poll showed that 120 citizens were in favor of building more parks in the community. The claim was made with 95% confidence. So that's okay. Right? 95% is one of our numbers. That the proportion of people who want to build more parks is 51%. But could be as low as 45% due to the margin error of 3%. The sample size was 250. Identify any misleading representations. Okay, so let's see. They said x equals 120. That's the favorite, right? And n here is 250. So p hat equals x over n, which is 120 over, that's a 0, 250. And if you do your math, this will get me 0.48 with a margin of error. So 0.48, p hat is 0.48, and that's in the middle. Because if you take p hat plus e and p hat minus e, you will get 0.48, and the margin of error was 3%. You'll get 0.45 and 0.51 or 51%. But what they're showing here, though, they're showing a high of 51% and claiming that as their highest possible estimate for the population proportion to give an impression that the proportion of people who wants the park is greater than 50%, but that's not the case. So the error is using the high estimate. Using the highest possible estimate as the population estimate. So in other words, it should be 0.48 rather than using just 0.51. Does that make sense? So they're just kind of using the wrong side of the spectrum. Well, that was lesson 8.50. We're talking about taking the sample data and making inferences about the population. Remember, think about that candy machine. You put in some quarters and you get some Reese's Pieces out of it. And the Reese's Pieces can tell us about all of the pieces in the candy machine. We'll see you guys later.
We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today. Listen up and behave. We doing math today. We doing math today.